And here today we're showing off some of our latest streaming and simulation technology running on an iPad and a Vision Pro. Yeah, that's right. And so what you're seeing right here is of course, a real McLaren 750S. And then back behind the scenes, we're running a real-time simulation of how air moves over all the aerodynamic features of this car. And because we're running it in real time, we can actually interact with it directly on the device. So I can move it to different portions of the car, and we can sort of see how the air moves over the different features. I can even move it to the back and let you see through the car, and we can actually track the air and how it moves over the front diffuser of the vehicle, down below it, and out the back. Now the real use case here is we want to bring design and engineers closer together in the development of these vehicles. And so what we can do is we can even do things like modify if the wing is deployed or retracted, and we can see how it affects the air velocities in real time. So this is a demo that we've built for today, but it's running on top of a bunch of different libraries that we build at NVIDIA for developers. Down at the core is our CUDA-X libraries. That's what's accelerating things like the physics simulation of the air. That's with our physics AI team. Next, we render those physics simulations inside Omniverse, which is our SDK for building real-time applications that will display the simulation and allow me to interact with it in real time. And then our spatial streaming stack is what allows us to stream the render of that simulation to devices like the iPad and the Apple Vision Pro in real time. And we call this sort of our hybrid compute stack. And what that means is that we're sharing the compute load with the iPad and the Vision Pro. The iPad's doing all the world tracking, keeping the streamlines locked to the car. It has all of our interactions on it. And then our Omniverse application in the background is what's doing all the rendering and sending all the pixels of the simulation back to the device.
So yeah, what we see on this screen, on the actual car, and I'm sure you've tried the iPad and the Apple Vision Pros. Here, what you're seeing is the using Apple Vision Pros and technology and spatial technology to be able to render the simulations from CFD on top of the real car geometry. And what you see here is actually a different concept where you have a digital twin of the vehicle. So this is actually rendered thanks to our Omniverse platform. And what we have here is that we're bringing in like all the information about the geometry of the car, the styling of the car with all the materials and the lightings and so on. And as well, we're able to bring in the information from our computational fluid dynamics simulations. So in this case, what you can see here is actually a view where you have all your streamlines, and you're able to visualize them on top of the car, so you can effectively see the aerodynamics on top. And you have other visualizations as well, like slices, which is often something that engineers look and are very interested, because then they would analyze the aerodynamics around the wake or around the rear wing and so on. And what's super interesting is that what we developed as well is we have a physics AI model. So we have a physics AI model that is trained using our physics demo platform, and it has been trained on hundreds of simulations. So what it allows us to do is that because it has been trained on hundreds of simulations, we can use the AI model to predict the result of a new condition or a new geometry in real time. So for instance, if I now try a different wing angle, like I've brought down the wing angle, I can use my physics AI model to make inference and see the updated aerodynamics in real time. So this kind of real-time feedback for engineers, it will become invaluable because it will allow them to basically change their geometry or update their conditions and see in real time what the effects of the aerodynamics is, compared to traditional workflows where you have to run simulations that might take hours to run, right? And then the other thing that we have built on top is actually an agent. So this is actually an agent that allows you to interact with both the simulation data and with the visualization platform. So for instance, I can ask the agent to switch between streamlines or slices. I can ask the agent to, for instance, increase the wing angle. So I can show you again. Increase the wing angle to 60 degrees. And then the agent, which under the hood is actually using our Nemotron models. So Nemotron is our family of open source models specifically trained for agentic purposes. So you see that it has increased the flap angle, and it actually has also requested a new inference of the physics AI model. So then the agent can basically interact with your simulation data and with your visualization. It can even actually use a vision language model to analyze what it's seeing. So for instance, I asked it here to capture the viewport and tell me what you see as an aerodynamicist, right? And it prepared for me a nice report where it explains, for example, the areas of turbulence. It talked about the underbody aerodynamics based on what it was seeing. And then actually what you can actually also do is that you can ask it to generate a report with all the findings. So we believe that this can be very powerful because as we speed up all the simulations, and we also give you the tools with things like Physics Nemo to build these AI surrogates, the analysis of the simulation is also going to be becoming a bottleneck and something where we think agents can help you a lot. And we can have an agent generate for you the reports and also use the historical simulation data to inform you about what are the next steps in your design that we think you can do.
So if you think about robotics and automation, the industry existed for the last 50 years plus. But all those robots have been programmed by humans, which meant that the only place you could afford to have a manufacturing robot happens in high volume deployments, automotive and high volume electronics manufacturing. Because there's such a big volume, you could afford to hire engineers to program the robot. That's basically what happened today. But much of the world in manufacturing happens in small and medium enterprises, as you know, and they maybe need 1 or 2 or 3 robots, and they can never afford to program these robots because the cost of programming these robots is extremely high because the volume is low and the number of tasks are high mix, as we call them. So you need AI to come to solve this problem. So 2 things are needed from AI. The first thing that you need for AI for manufacturing is the accuracy of the robot needs to be very high for all those different tasks. That's number 1. Number 2, you need to be able to deploy that robot into your workflow, into your manufacturing flow. There also agentic AI can help. Instead of the human programming the robot, the AI can program the robot based on the general purpose brain. So right now, what's happened in the last 12 months, because of generative AI, large language models, vision language models that have been used in the digital world, that technology is being brought into the physical world, into robotics and physical AI. And then once you build that AI, you have to test it first before you deploy in the manufacturing world. You cannot afford to try and test this in the real world because many times it would fail. So the answer is you have to do it in simulation. So simulation technology also in the last few years has matured now, where you build the general purpose robot brain, you test that in simulation first. Once you like the answer, then you're going to bring it in the real world. And we are seeing that evolve extremely fast in the last 12 months. And here you see an example behind me is a perfect example where the robot is a cobot arm from Universal Robotics, been available for many years. But instead of programming that robot, there is a robot brain by this company called Skilled AI. It's one of the companies that Jensen showed in the keynote yesterday in the AI natives. They're building a general purpose robot brain that you just tell the robot what task to do in text or in instruction, and the robot can automatically be programmed by the general purpose brain. So you can